Okay, example 1 says solve by graphing. All right, now, let me just give you this one disclaimer. At no point for the entire year am I going to say on a test, solve by graphing. Okay, it's not efficient. All right, elimination and substitution are both very efficient. Graphing is not efficient. Okay, but for the sake of the homework problems, when it says solve by graphing, it gives you practice at solving, by graphing lines and also finding points of intersection. It's a lot of good math involved in this technique. But again, efficiency is not one of the things you get out of it. So, if I'm solving by graphing, job 1 is to get this equation to write, say y equals everything else, which it already does. Alright, and if I have y equals everything else, focusing on the highlights of the equation, the number that is all by itself, which is this number here, is the y-intercept. So if I draw an x and y axis over here, there's my x-axis, here's my y-axis. And I'm going to label those axes x and y. And again, I want you to be in the habit of doing that every time. The positive x-axis, so off to the right, put the x. Positive y-axis going up, put the y. That's where they belong. So when I go to read your graph, I expect to see the x and y-axis labeled just like that to know exactly where the top right-hand corner of your graph is, so it's going the right direction. The y-intercept simply tells me on the y-axis I'm going to put a dot at positive 1. One space above the origin. Alright? If it says minus 5, I'd go 5 below the origin. So again, it's up or down, up, positive, down, negative on the y-axis. And again, that's whatever this number is here, that tells me where that is. The number in front of x is the slope, and slope is a fraction always. So if it's not written as a fraction, put it over 1 so it looks like a fraction. And it's positive 1, so either positive 1 over positive 1, which is up and to the right. It could also be negative 1 over negative 1. That also makes a positive 1, right? That would be down and to the left. What that tells me is how to get from a point on the line to another point on the line. And this blue point I just put down is a point on the line. So if I want to go up 1, right 1, up 1, right 1, again and again and again, I keep on getting points on the line. If I go down 1, left 1, again and again and again, I get points on the line. So all those are points on the first line, y equals x plus 1. So if I then connect those dots with a nice straight line, that is the graph of y equals x plus 1. The second line is y equals negative 2x plus 4. So again, looking at a good slope-intercept method, negative 2x plus 4. Again, I like my slope to be written over 1, so negative 2 over 1, so I'm going to write it. Once again, the number that is the constant is the y-intercept. So I start at positive 4, 1, 2, 3, 4. And the slope of negative 2 over 1 is going down 2 and right 1. Or it could be 2 over negative 1, which is up 2 and left 1. So if I go up 2, left 1, up 2, left 1, or if I go down 2, right 1, down 2, right 1, it doesn't matter which direction you go. Start at the point that we got the y-intercept and then just apply the slope to get the other points. We connect those dots with a nice straight line, like so. And now both lines are graphed on the graph paper. The point of intersection of the two graphs represents the answer. So this right here is the answer. And if I look at its coordinates, I'm going right 1 space, up 2 spaces. So the correct answer to this problem is 1, 2. And that's how you solve a system of equations by graphing. You graph both lines, identify the point of intersection. That's what we're looking for every time we do these problems. Before, when we used elimination and or substitution to these problems, we're still finding the exact same thing, the point of intersection. We just didn't see a graph to represent it. So that's the difference in what we're doing today. Again, same type of problem, same type of answer. No matter how you go about doing it, you're going to get that answer for this problem.